Welcome back to Math 103. This is video number 6 on fair division. Our example from last time involved dividing up a large piece of land among 4 siblings who have inherited it, and a neutral mediator comes in to divide up the land into 4 shares, 4 parcels of land, and the hope is that there is a way to divide these specific 4 pieces of land among the 4 siblings so that everyone will get what they consider to be a fair share, according to our definition of fair share. Last time we saw that Eve has as her fair shares S2, S3, and S4 because her minimum fair share amount, we computed last time, was $500,000. So any share worth that much or more is a fair share for her. It is acceptable to give her any one of these shares, and she won't file a lawsuit afterwards for being shortchanged. To answer the same question about the other 3 siblings, Fred, Gail, and Hank, we have to use the same methodology. So first, for Fred, we add up the total value of all the land according to him. And notice, he thinks the entire piece of land is much less valuable than Eve thinks it is. That's okay. They will have different opinions about this. I mean, Eve might look at share 3 and think, what a fantastic investment opportunity, and have specific ideas in mind for what she could put there. Fred might look at it and see it quite differently. So it's entirely plausible that they have different valuations of the different pieces of land. Very well. So knowing that 1.2 million is his total valuation of all the land, 1/4 of that is his minimum fair share amount. So he is entitled to a share worth at least $300,000. And wouldn't you know it, he happens to value each one at exactly $300,000. So his list of fair shares, for him, consists of all 4 of the shares S1, S2, S3, S4. For Gail, when we add up her valuations of the 4 parcels of land, they too add up to $1.2 million in total, and she too therefore has a minimum fair share value of $300,000. However, according to her, since it is somebody else who has put down the orange cones that separate these 4 pieces of land, these 4 parcels from one another, she looks at those 4 pieces of land and thinks that S3 is the only really good one. She has a very high opinion of S3 and its value, and a much lower opinion of the value of S1, S2, and S4, and so only S3 lives up to her threshold, her minimum dollar amount for a fair share. Finally, Hank values the entire piece of land at $1 million total. A quarter of that is $250,000, so any share that's worth $250,000 or more is a fair share for him. It doesn't have to exceed $250,000, it could equal $250,000, and it will count as a fair share for him. Great, so we have found for each sibling, and we found this for Eve earlier, we have now found for each sibling which shares they could accept and regard them as fair shares. The goal, ultimately, is to give each sibling one of these 4 parcels of land so that each sibling will get one item from his or her list of fair shares. Well, how can we do this? One thing is for certain. We see right away that Gail must receive S3. It's the only one that she will be satisfied with. It's the only one that counts as a fair share for her. So we start this process by giving Gail S3 and work from there. Notice that Fred will accept any of these, so we don't have to work around him particularly. Eve will take any of S2, S3, S4. Hank will also take any of S2, S3, S4. So Fred is the only one who will accept S1 as a fair share. So he certainly gets S1 if this is going to work at all. That leaves us giving Eve S2 or S4 and giving Hank the other one. We can do this in either way. Okay, we can give Eve S2 and then Hank S4 and then everyone's happy, or we could have done it the other way around. We could have given Eve S4 and Hank S2. From the point of view of just making sure that everyone gets a fair share to them, this is perfectly fine, and the other way is perfectly fine we're not worried beyond just making sure everyone gets a fair share for them. We have enough information in front of us that if someone proposes a specific way of divvying up these shares, we can evaluate whether it's fair or not. So I claim that the following proposed division is not fair. So take a moment, stare at this, and see if you can figure out what's wrong with it. So the real problem is trying to give Gail S2. That is bad news, right? Eve getting S3 is okay. Fred getting S1 is okay. Hank getting S4 is okay. When I say okay, I mean in and of themselves, these are acceptable shares to give each of those players, but the unacceptable thing to do is to give Gail S2. It's just not allowed. So the key point to remember throughout this topic is that the one thing we are not allowed to do is give a player a share which isn't a fair share to him or her. So far, we've been looking at a number of examples and obtaining fair divisions for them in a more or less ad hoc way. There was some systematic reasoning in the previous example, but what we really want is to find systematic methods which guarantee a fair division. In other words, methods which guarantee that as long as everyone follows the method carefully, each player is guaranteed to receive a share worth at least 1/nth the value of all the goods to them, where n is the number of players. Okay? We want it to be guaranteed that every player receives a fair share. This is mathematics that we're doing, and guarantees are really very important. So remember how in the voting theory chapter, for example, the instant runoff voting method was guaranteed never to violate the majority criterion. In the previous chapter, we saw how Hamilton's method is guaranteed never to violate the quota rule. Similarly, we want fair division methods that are guaranteed to produce fair divisions, guaranteed to give everyone a fair share. To approach this problem of finding systematic methods that are guaranteed to give us fair divisions, we have to start out making a key distinction between dividing up continuous goods and distributing discrete goods. Continuous goods should be thought of analogously to the cake we started thinking about early in this chapter, and discrete goods should be thought of analogously to the microwave, which it would be pointless to carve up into 4 separate pieces and distribute among the roommates who jointly owned it. Okay? So continuous goods, like a cake, like a piece of land, like the calendar and a timeshare, can be cut up any number of ways. There are no inherent points where you have to make the cut. You can make the cut anywhere, whereas a microwave is the kind of item that you don't want to cut up at all. Either one roommate should get the microwave, or they should sell it and split the cash. The rest of this chapter will develop systematic fair division methods for continuous goods, and then the next chapter on fair distribution will do the same for discrete goods. Our fundamental method for dividing continuous goods, when there are 2 players involved, is the divider-chooser method. Okay, this systematically enables 2 players to find a fair division of continuous goods, and it guarantees that if they follow the rules, both players will indeed get a fair share. Let's describe the rules, and then we'll look at some examples. So the divider-chooser method says that first you flip a coin to decide which player is the divider and which is the chooser. Whoever turns out to be the divider, this is determined randomly, divides the goods into 2 shares, which must be equally valuable in his or her own estimation, equally valuable according to his or her own value system. This is very, very important. So the divider has divided all the goods into 2 shares, and now the chooser selects one of those shares, and then the divider will get the other. The chooser selects which share to receive in its entirety. The divider will get the other share in its entirety. No part of the goods will be left over. Before we get into more heavy-duty examples, you may find it helpful, and/or amusing, to see the divider-chooser method in action. So the next video, number 6A for fair division, is a classic 30-second commercial for Jif peanut butter, in which 2 young brothers apply the divider-chooser method to a peanut butter sandwich. You'll especially enjoy the best line at the very end, "I got a pretty big half." Think about that. I got a pretty big